Now, generalizing what we've seen here a little bit, we've seen why, if x is a multiple of t, that t is just going to be a multiple of x. That's x multiplied by reciprocal vx, a constant multiple of x, so that when we plug in that expression for t, we're going to get an x squared. And it's a multiple of x squared. So y is going to be a multiple of x squared. We're going to have the parabolic graph. More generally, if x is any linear function of t, so if x is our typical v naught xt plus x naught, and y is a quadratic function of t, and that's exactly what we're going to get if we have zero acceleration in the x direction and a non-zero constant acceleration in the y direction. Okay? No matter what our initial position is at whatever initial time, we're going to get something like this. Okay? We can always get our solution into this form. Okay? Will this give you a parabola? Well, we don't have to work out all the algebra, although we could and probably should for practice, but we don't have to work out all the algebra to figure this out. We simply observe that, well, x is a linear function of t. Well, if x is a linear function of t, then if we solve for t, we're going to get a linear function of x. Now, you maybe have to understand linear functions well enough to understand that, but, you know, if y equals mx plus b, then x equals what? Okay? It equals y minus b over m, which is, you know, y over m minus b over m, and that's a linear function. So clearly if we solve this for t, we're going to get a linear function. And I actually did that. If we eliminate t here, our t is going to be this, which is going to be this, and that's a linear function of x. So that's linear in x. We didn't have to solve it to know that if we understand linear functions. If we don't, we probably have to solve it, and then we understand that about linear functions. Either way, it's okay. Since t is linearly related to x, then when we plug in for this t, we're going to get something that's a linear function of x. Okay, when we plug in for t squared, well, our linear expression in x is going to become a quadratic expression in t, isn't it? So that this is going to be quadratic. I think our linear function in x, when it's squared, will become a quadratic function in x, not t. Okay, so this is going to be a quadratic function of t, this is going to be a linear function of t, and this is going to be a constant number. Well, if you add a quadratic function of, and I said in t, if you add a quadratic function in x to a linear function in x to a constant, you get a quadratic function in x. So, I say here, t squared is quadratic in x. So, therefore, is 1/2 ay t squared, because this is just a constant. If you multiply a quadratic function by a constant, you still have a quadratic function. And so is this, and so is this, okay? This is actually linear, this is a constant. Well, dot, dot, dot. This is a quadratic function of x, so is y. Y is a quadratic function of x. And we conclude that if ax is 0, which is what gives us this, and ay is constant, which gives us this, our path is a parabola. That's all there is to it. Okay. Now, we're going to apply some of these ideas to a specific situation, to projectile motion.